Next we come to a question. In this question we have to predict the geometry of NiCO4 and NiPPS3 whole twice Cl2. First of all, you are going to find the oxidation number, and the basis of oxidation number you can predict which ligands are going to be strong and which ligands are going to be weak. So in this case, NiCO4, CO is a neutral ligand. Ni plus 4 into 0 is equal to 0. So the oxidation state of nickel here is 0. So this is a complex in which the oxidation number of the central metal atom is 0. That means the central metal atom is an atom and not an ion. So nickel has the electronic configuration 3d8 4s2. In this case, NiPPS3 whole twice Cl2. So this is NiPPS3 whole twice and Cl2. If you calculate the oxidation state in this case, the oxidation state of nickel comes out to be plus 2. That means 2 electrons it has lost. So the electronic configuration of Ni plus 2 is going to be 3d8 because the 2 electrons are going to be lost from 4s. So if we draw our d orbitals, let's draw the d orbital. This is the 3d orbital, then we have 4s and 4p, and fill in electrons in it. So there are 8 electrons in 3d, that is makes it 8, and 2 electrons in 4s. Now CO is a strong field ligand, okay, but what it does is, instead of pairing up just these 2 electrons, it depairs the s electrons first and makes them pair with this. So the s electron or the s orbital, it becomes empty, the s orbital it becomes empty, and the pairing of the electrons it happens in this. The electrons from the s orbital, they go to the half filled orbitals of the 3d. So the 4 CO ligands, that is the electron pairs of the 4 CO ligands, they come into sp3. So the structure is tetrahedral for NiCO4. For NiPPS3 whole twice, let's do that in another color. So for NiPPS3 whole twice, this is the d orbital, 1, 2, 3, 4, 5, 6, 7 and 8. Then we have S and then we have P. PPS3 is not that much of a strong ligand. It cannot pair up that well. So what happens is, the ligands from the PPS3 as well as Cl2, they come into, okay, one second. So they come into this. So the structure again is tetrahedral. So both of these have a tetrahedral structure. In this case, the Cl is present inside the square bracket, not on the outside, it is present inside the square bracket. So on the basis of the strong field ligands and the weak field ligands, you can see how we can predict the tetrahedral structures of complexes. Similarly, we can predict whether structure is going to have octahedral or whether it is going to have a square planar structure.